Firewalls at the application layer versus the network layer. By now you know all about the OSI model, and that the application layer is at the top of the heap and the network layer is a third one up from the bottom. As a rule of thumb, the higher you get in the OSI model, the more complex the interactions become. This rule holds true for discussions of firewalls that work at the application layer versus those that work at the network layer. The firewalls that were developed functioned solely at the network layer, and the earliest of these were known as packet filter firewalls. I converted the packet filtering a bit earlier in this chapter as a refresher, as it means that the firewall looks at an incoming packet and applies it against a set of rules in the ACL. If the packet passes, it gets sent on. If not, the packet is dropped. This type of filtering is pretty basic because all the firewall considers is the individual packet. All that matters are the source and the destination address, protocol and port number. The firewall doesn't care whether the packet is standalone or part of another datagram. The process works fairly well for common protocols such as TCP and User Datagram Protocol (UDP), which communicate on predefined port numbers. People generally refer to two types of network layer firewalls: stateful and stateless. Stateful versus stateless network layer firewalls. As I said in the last section, a basic packet filter doesn't care about whether the packet it is examining is standalone or part of a bigger message stream. That type of packet filter is said to be stateless in that it does not monitor the status of the connections passing through it. Again, these work pretty well, but the firewall has no idea whether a packet is legitimate or possibly a rogue packet trying to sneak by. These types of firewalls tended to be susceptible to various DOS attacks and IP spoofing. The one big advantage that a stateless firewall has over its stateful counterparts is that it uses less memory. Today, stateless firewalls are best used on internal networks where security threats are lower, and there are few restrictions in contrast to a stateless firewall. A stateful firewall is one that keeps track of the various data streams passing through it. If a packet that is part of an established connection hits the firewall, it's passed through. New packets are subject to the rules as specified in the ACL. These types of firewalls are better at preventing network attacks that look to exploit existing connections, or DOS attacks. A stateful firewall works by using the TCP three-way handshake. First, a client sends a packet with the SYN bit sent to the firewall. The firewall interprets this as a new connection and passes the request to the appropriate service provider on the internal network. Next, the service provider responds with a packet that has both SYN and acknowledge bits set. Finally, the client responds with a packet with only the ACK bit set. At that point, the connection is considered established and the firewall will only allow packets in that have the same connection identification. The established connection is logged in the state table. If there is no data on the connection for a specified period of time, the connection will time out in the state table. Any new communication will need to be re-established based on the ACL rules. Stateful firewalls tend to be a bit slower at establishing connections than stateless ones because there is more to do. After the connection is established, though, stateful firewalls are usually faster because they have to check the state table for the connection instead of comparing the packet against all the relevant ACLs. This is done via packet inspection. Most stateful firewalls can also keep track of connections using connectionless protocols such as UDP. NGFW Layer 7 Firewall. Although stateful firewalls are more powerful and secure than stateless ones, application layer firewalls are also called next generation firewalls. NGFWs or layer 7 firewalls are even better. They work by inspecting more than just the data in the IP header. They read data at the application layer. In other words, they will know whether the packet is FTP, SNMP, HTTP or whatever application layer protocol it is. The one major drawback is speed. Because these devices have to read more information than their network layer counterparts, they tend to be a bit slower. It's generally not enough that you'll notice, though, unless you have a reaction time of Superman. One nice feature of application layer firewalls is that they let you set proxy rules for multiple applications on the same firewall. As a proxy, the firewall processes all data between the two endpoints and drops all packets that are suspicious. In theory, a rogue packet will never reach the system on your internal network. Application layer firewalls also handle complex protocols such as H323, which is used for voice over IP VoIP, much better than their network layer counterparts. Scanning services and other firewall features. Most firewalls are capable of performing scanning services, which means they can scan different types of incoming traffic in an effort to detect problems. For example, firewalls can scan incoming HTTP traffic to look for viruses or spyware, or they can scan email looking for spam. You can often set scanning rules to prevent users from downloading files over a certain size. On Cisco routers, scanning is administered by the Content Security and Control Security Services Module CSCSSM. Two categories of content which are typically scanned: mail and web. Table 15.1 shows some key default scanning settings with CSCSSM. So mail SMTP POP3 scans all files in an email. Mail SMTP and POP3 reject all messages larger than 15 megabytes. Mail SMTP rejects messages addressed to more than 100 recipients. Mail SMTP cleans emails or attachments containing malware and attaches a notification that the malware was deleted. Web HTTP scans all file downloads. Web HTTP scans web mail sites for AOL, SMN, Google and Yahoo. Web FTP scans all file transfers. Web HTTP and FTP skips scanning of files larger than 15 meg. Can also enable deferred scanning. Web HTTP and FTP cleans files in which malware is detected, deletes files that cannot be cleaned. The defaults give you a pretty good level of protection, but there may be instances where you want to change settings. For example, if you are concerned about bandwidth, you can limit the size of files transferred via FTP or HTTP. If mail storage is an issue, you can set the firewall to reject mail larger than 10 megabits per second. Keep in mind though, by changing some settings you are increasing your security risk. If you offer deferred scanning for larger files, it will allow you to begin viewing the data without a prolonged wait while the entire body of information is scanned. However, the unscanned portion of the information can produce a security risk. Content filtering. Content filtering is very closely related to scanning services, and on Cisco routers it's also provided by the CSCSSM. Specifically, content filtering means blocking data based on the content of the data rather than the source of the data. Most commonly, this is used to filter email and website access. The reasons for content filtering seem pretty obvious. Most companies have a zero tolerance policy against hateful material or pornography. If a user on a company network uses that network to spread hate mail or porn, that company could be liable for damages in a lawsuit if they didn't take measures to prevent such actions. It's not only a moral issue, it's a legal issue too. Content filtering is also important in places like schools. It's doubtful that parents want their kids to be able to stumble upon a porn site in the school library while researching a school project. Content filtering can block that site from being accessed, so the problem never occurs. You can find several parental control software packages for home use that employ content filtering. There are several ways to filter content. Here are some of the more common categories used. Attachment. Blocking attachments of a certain type, such as exe files, Bayesian content encoding, email headers, language phrases, promixity of words to each other, URLs. Nearly all filtering methods use a combination of filters to protect users from inappropriate content. Signature identification. Firewalls can also stop attacks and problems through a process called signature identification. Viruses that are known will have a signature, which is a particular pattern of data within them. Firewalls and antivirus programs can use signatures to identify a virus and remove it. The same holds true for other software bugs such as worms and spyware. Numerous network attacks have signatures as well. For example, if your router starts getting hit by large SYN requests, you may be at the beginning of a SYN flood attack. The intonation of SYN traffic is a signature of a SYN flood. Context awareness. A firewall that is context aware is one that can take into consideration the context in which traffic is arriving at the firewall. It can detect different applications, users and devices, not just IP addresses. Because of this more sophisticated approach, it lets administrators track how applications are used across a range of devices. For example, it may track and or prevent the posting of sharing of videos on Facebook using an iPhone, PC or other devices. It also enables companies to enforce policies like not allowing a specific group of employees to access games on iPads. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.